My name is Andrei Melis. I'm from ModeWeb, the organizer here. I hope you have a good time in Bucharest. What I'm going to speak today is a case study of one of our past projects about visualizing statistical linked data with Plone. First, just a few words about open data and linked data, for those of you not already familiar. There is a classification of various level of compliance, not compliance, but recommended when publishing linked data. First, that it is on the web and in whatever format, but an open license. Then structured data, for instance, Excel instead of scanned PDF. By the way, here in Romania, we are still at level 1, I guess. The national budget is, or was until last year, published as a scanned, signed, and stamped paper. But we moved on, I hope. Third, in a non-proprietary open format like CSV instead of Excel, although I think we can consider Excel open. Still, everybody knows to read Excel. And then it becomes more interesting, and we're moving towards linked data, specifically to use URIs or URLs or any unique identifiers to denote things, so people can point at your stuff. And then to provide some context and linking to others' data in order to offer a better understanding of your data and try to get out of the silo, let's say. This is mainly for data publishers. As guidelines, there is some more information on that website with costs and benefits for each level. So it is recommended that when you use URIs for data for anything, like for instance for Bucharest on DBpedia here, this is resolvable through HTTP and through a content negotiation. For instance, if you ask for using an HTTP accept header, this is one of the methods to redirect based on the requested format. And clients that are aware of RDF, for instance, or linked JSON, to be responded with a machine understandable format, while a regular browser to be shown just a web page. This is what is served from DBpedia when you look up org resource Bucharest, for instance. I just found out a new word. It is a primate city. It seems that Bucharest is a primate city, which doesn't mean what you might think of first. Okay, so I'll try to be short. During the last, I don't know, 5 years in Europe, maybe earlier in US, there was a variety of open data portals, like catalogs of data sets, of open data sets, related, I think, with EU directive on reuse of public sector information. So basically every governmental and public institution was recommended to do that by a law. So you can find out, besides the Open Data Hub IO, which you might know, there are others. There are, I think every European country has one, DataGov, Romanian or UK or Ireland and so on. Also, there is one in US, and Open Data Europa EU is the portal made by the European Commission. They do not contain data, all data by in the portal. Is just a catalog and linking to the actual location of the data. So at first, linked data was produced by academic and research projects and web enthusiasts by converting existing data to RDF, but was adopted slowly, I would say, but it's still, there is this famous picture you might know. It's still growing year by year with linked data and producers. You cannot understand anything, but there is a SVG version on the website and how it links to each other. And in the middle, there is GeoNames and DBpedia. But this project of ours was related to statistical data. It was a project for one of the DGs in the European Commission that are a producer of statistical data. So we found out that statistical data is very different from the typical linked data with a list of countries and cities and persons and so on. It is, the structure is usually similar. It contains indicators and data series and time series and geographical regions and so on. It is multidimensional data, although any data set contains a time dimension and a geographical dimension. There are also specific dimensions and other things like slices, totals, denominators, percentages, and so on. So it was challenging we had to create also the data set in linked open, as linked open data. So we had to think how to link it, what to link it to. So first we searched for what format. We knew what the data was about, and we searched a model for that. There are various RDF vocabularies, but in the de facto standard is SDMX, which is an XML-based standard, which was developed since 2000 and something. So it was already adopted by most of the big names like Eurostat and UN and World Bank. There is also the dataset publishing language, which you might know from the Google Public Data Explorer. They are very similar, and they are also very similar to the RDF correspondent, which is RDF Data Cube vocabulary. It is based on existing vocabularies like good old Dublin core terms, decade and void. Those were concerned with each one with a particular thing, but RDF is built on top of them and integrates. You can use it to model data set, its metadata, the dimensions, the code list, and the data points itself. It is a W3C recommendation since last year. So actually, this is what we used. It was more of an experiment, let's say. There was a research component in the project to use it. I wouldn't normally pick that if I had to. But we discovered that there are also some advantages and also some downsides to visualize data expressed in RDF. Among the advantages, I would say the extensibility of the data. You can easily merge to RDF graphs, and the federated queries that you can perform on using Sparkle query language. This is a strange language. It's easier to read than to write if you are not used to it, but in the end, once you get used to it, it's not more complicated than SQL or, I don't know, XPath. This is just an example of what you can do with it, with this endpoint. The endpoint, it's like a server, like an open database, let's say. It works over HTTP. And on the server side, there is this Sparkle, the RDF triple store that can speak Sparkle. So just as an example, I took this endpoint from the World Bank. It's actually not from the World Bank. It's from server converted data during a research project called Linked Data Spaces. It was a project from Leipzig University, and they converted various formats of data into this RDF data cube. So you can actually, even if you don't know anything about the contents, you can try to start from something familiar, like this concept of temperature from DBpedia. So I just try to see if there is anything there about temperature. And there was actually something. This one, it's an indicator called variable TAS, which was defined as an exact match for DBpedia temperature. And then, because the URI is resolvable, I could actually navigate to its page and see what it is about, that it is in Celsius, that it's part of a larger concept scheme called climate, and that climate contains other things like precipitation and cold days and so on. Okay, so you can actually discover very easily more related indicators and facts and data starting from something very common. It's because data cubes have a predictable structure. They must clearly define their dimensions and the structure of the cube. It's easy to get to the page of the data set. And I discovered that there is this historical data set with average temperatures. It has its own metadata, relations with other. There is a link to the bulk download of data, a license, of course, and I can query it also by using Sparkle. This is a more complicated query. Basically, it says, give me all observations. These are the data points from this data set. For Romania, about temperature and about October, measured during October. As you can see, I haven't used anything that is specific to the data producer. I only used links to DBpedia because I knew they were there. And there is a result. It's actually a very exact average, 10 degrees. I don't know if they measure also the night, but we seem to be in the range. So every data point in this data set has its own page and its own properties. You can see it. And this is a page generated by so-called linked data browser. There are a few tools available. It's more for, it's a humor-readable version, but you can also develop a tool that understands Sparkle and RDF, and this is exactly what we did. A generic tool for exploration of data sets and creation of graphical representations where users can also see the code lists and definitions and all sorts of explanations. This is a website where the tool is available. It has been used by the Commission since 2013. It was developed by DG Connect, and they have to promote this sort of emerging technologies because no one else does if somebody doesn't start. And it was meant to be an alternative channel to disseminate their own measurements and statistics about how European countries are progressing in the so-called digital agenda. It's part of Europe 2020 strategy. So this is what we use. We use Plone. Actually, it's a longer story there. We proposed, it was a tender, we proposed to Plone and EA Davies, which you might know. It's also a tool to create graphical visualizations from semantic data. But it was already developed for 1 year or so at that time. Since then, it has evolved a lot. It's a flexible tool to provide, to create small visualizations from small data sets and to publish them on the web. But after a few discussions with our customers, we decided to fork from that and to choose a different path, and because of the specific requirements. So we just picked HighCharts as a JavaScript library. We kept some components from the backend to perform Sparkle queries, but we just went with 2 content types, very simple. This will not be a very technical presentation, and I'm not a Plone developer, so in case you want to ask me, I will not show any code. We compromised a bit on the front end, and most of it was developed in JavaScript with Backbone. Okay, because of, as I said, specific user requirements, and they wanted to create something very, very simple for the non-technical audience, like journalists and politicians who are not very okay. And also the project officer, the responsibles from the commission were not very technical as well, but I couldn't put that in the presentation. So they wanted lots of explanatory notes and labels and titles and metadata and all of this configurable. So there isn't any chance that the official data from the commission would be misunderstood. Moreover, they had a very large data set with more than 100 indicators, historical indicators since the 2000s. And they wanted to have a sort of browsing through that data set. And anyway, this is what EA Davies was not a very good choice. Besides that, just the usual features to embed and export and bookmark and so on. Very important aspect was how they look. From the CMS, we didn't use that much, just some basic content types and moderation comments and publish, unpublish feature. Of course, a theme that we wrote, and we managed to disguise very well Plone. You can say it's a Plone there. And some custom pages, of course. So with this tool, you can just enter a Sparkle endpoint. It will show you what data sets are inside, extract the metadata and show it, and then you can just first see what information there is. It creates its own page with description and license and so on. You can see the structure, the dimensions, and basically a visual presentation of the underlying data model. In a few clicks, you can just create simple charts like that. This is a chart actually from the Sparkle queries that I showed earlier, with temperature for Romania and from the dataset in the World Bank Sparkle endpoint. But I would say more than half of the project was then, of the effort, was spent to enhance and implement a lot of small details, small visual details just to show, to make it look better, to add a lot of descriptions and labels for each axis and so on. This is why we try to create a generic template engine that creates the charts, and separate from that, a separate module was a configurator for our users, not for our data publishers, where you can select, I will not go through all these details, but you can select mostly anything, the type of chart, how the dimensions will be shown as filters, the series, the sorting, the labels, and so on. A lot of configuration options. This is how it looks like in every panel from here. The code lists can be grouped in various ways and can be single selections. They wanted to have some sort of a faceted navigation, but without actual faceting, because this was actually a complicated decision. We wanted to be able to query remote data and also to be as real-time as possible. So indexing everything in an Elasticsearch or Solr was not an option. But we tried just to optimize the queries. Every selection in the navigation, in the filtering area, generates a Sparkle query behind, so it's like old school navigation. But it was acceptable after all, in the end. These are some examples of real charts from the website. There is here are the filters. This is the chart area with a legend, with title, with lots of titles and tooltips and everything. It's also possible to compare indicators from different places, from different data sets or different endpoints. Just use federated queries and show them on the same chart, even if the data sets have a different structure, because we know that they are statistical. They usually have a time dimension, even if it's called in a different name in two places. But there are some ways to label them and to know that that was the time. And even it's here, maybe you notice different time intervals. This is indicator that is quarterly, and this is an yearly indicator. So they can still be shown in the same chart. As I said, a lot of time was invested in these small details, but in the end, we have a good solution for this particular use case. It can extract all the metadata for the selection, the concept scheme definitions. It can export the image and the CSV data behind, and add comments, moderate them. Has a sort of navigation widget, let's say, where starting from a predefined selection, you can go to another different chart, but keeping the same selection. And after 2 years, this is they used it to publish these 3 indicators. In terms of size, they are not really small, but not large also. The biggest one has about 4 million triples. Some challenges, maybe stability and performance of the triple store. We were using version 6 of Virtuoso open source, and we had to be very careful with the queries. What else? Extensive use of caching, of course, for the Ajax queries. And one of the challenges was to create as much as possible something generic that can be used by others also. So in case you encounter this sort of scenario to visualize the data cube, RDF data cube, it should be fairly easy to set up. For more complicated examples, it's quite easy to develop new scenarios. In a couple of days of work, you can just hardcode on unexpected features, let's say. This is an example of a more interactive chart where users can select their own weights, and all the data is calculated dynamically based on the selection of each factor. Some useful links. There are some official use cases and other use cases and recommendation for those who have to do the same. And our documentation page here, the test website, it's open source. I didn't mention that. It's still on ODWeb's GitHub repository. Probably will be moved soon when the contract ends. And there is also a Vagrant setup with that builds everything in a virtual machine, including a snapshot of the current data, so you can get actually the real website. That looks like that. Just a second. This is it. This is the official website. It lists the data set. These are the administrator actions, and you can just browse data set. This was that interactive chart that I said about. It's actually pretty cool. I'm not sure how useful it is, but it is very useful when you want to compare countries, and I found it quite addictive to check all those all the indicators that are available. There are a lot of them. These are all the type of visualization already prepared by them. And there is also a sort of explanatory page where you can search by text search to see if there is anything interesting. Other example of charts. This is the metadata section. What else? This is, okay, the indicators. This is the actual speed on the test environment with the cache not warmed up yet. So it's, oh no, it's not. I don't have internet yet. Okay, that explains it. I do have internet. Huh? What? No. I don't know.
I see conference. The wireless?
No.
I see conference.
Oh, okay. Let's try it again. Okay, this is without the cache, and it's much faster with Varnish and Memcache on the production server. That's it, basically. Various type of charts, and it all depends on the data that you have to present. You can customize it. Yeah, I'm done. If you have any questions, okay.
Hi, this is very interesting from my point of view. We have Hi, so this is very interesting from my point of view. We have exactly this kind of information we'd like to present, and right now we have some custom products that try to achieve this. So you said this is all available on GitHub, basically, all this, and is it a product we can basically adapt to an existing Plone site?
Yes, there are 2 or 3 packages that you can use on Plone 4.3.
Okay. And it's only in the scoreboard build out?
That is just a
GitHub.
build out. There are 2 other or 3 other repos. We haven't yet packaged everything because it was still under maintenance, but you can contact me for anything.
Okay,
and it's very useful to check out the scripts from that Vagrant repository. This one. You'll have the presentation. This one was prepared by some other company. They are called 10 Force, and they are also working for the Commission, but in another project. It's called Open Data Support something. So this was just an exercise to see that the website can be handed over and installed by anybody, and it worked.
Okay, that's great. Thank you.
Okay. Okay, that's it. In case you have, I don't know, questions or you will need such a thing, just feel free to contact us. Okay. Thank you.